Let's say you're predicting the price of house. So that's regression. The classification is where you're trying to get the results in some sort of category, or we can call it them as the groups. Example could be, let's say the person is diabetic or non-diabetic. So looking at the person's various medical reports, it is categorized as diabetic or non-diabetic. In both the cases, we are aware of what type of output or the labels what we need. Also, they are available in the historical data. So here we have X and Y both. What if we just have the X? In that scenario, the common methodology under unsupervised is clustering. So clustering, as the name suggests, clusters. That means it's gonna form again the groups. So example could it be segmentation. It could be market basket segmentation, customer segmentation. That's the clustering. Now, when we talk about machine learning, how does this work? So what we need is we need data. It can be feature and label both, but what we need is we need data. This data is clean first, or we can say pre-processed. Then the data is passed to the algorithm. So one example of pre-processing could be if there is any missing data that is imputed, or if then there is any sort of, let's say, a missing element that will be added or it will be removed. The algorithm will be implemented based on the data, based on what category or what problem statement we are looking at. For each and every category, like regression, classification, clustering, there are thousands of algorithms are available. So we can implement based on our requirement. The algorithm will be implemented and algorithm is going to provide you the output. This output can be evaluated. What does that mean? Is it performing on the data good or not? Now this data is going to be the training data. And there will be a testing data as well. Using this testing data, the algorithm will be evaluated. If it is providing you a good evaluation, it will be deployed. That means it's available now for the production. So based on regression, classification, or clustering, what you're using, the evaluation method may vary. So this is whole and soul about the machine learning. Now why we spoke about this? DP100 is a path which allows us to work with Azure machine learning. Azure machine learning, it provides a platform for the data scientist so that you can train, you can deploy and manage the machine learning models on the Microsoft Azure platform. It provides a comprehensive set of resources. So various resources required for the training along with the assets. So to train to deploy effectively the machine learning models, the assets and the resources, what we require, that will be provided by Azure Machine Learning. And this is available where? Over the Microsoft Azure platform. So what exactly is your machine learning service and how are you going to create? That we are going to see a little bit of it today. So first, if you want to create Azure machine learning service, what you need is you should have access to Azure platform. Then you sign in to get the access to Azure subscription. Then you're going to create a resource group. What is a resource group? Consider resource group as a folder or a container where all the resources and assets required to perform a particular project you can keep under one hood. You're going to create next is the Azure Machine Learning. This service is what we require to work with machine learning tasks. So this automatically creates the storage account, the key vault, and the application insights. Storage account will help you to store all metadata and artifacts. Let's say you're writing a code in a notebook where it will be stored in the storage account. there could be possibility that to work with the Azure machine learning, you're pulling out some data. That data can also be stored in the Azure storage account. So that's why we require storage account, which will be auto-created when you're creating Azure machine learning service. Apart from that, there will be a keyword which will be auto-created, where you can store and manage the secrets, such as authentication keys and credentials. So to access to the resource, if you require any sort of, I would say, the keys or the credentials, and you want to create those kind of, I would say, secrets, which you can pass along to other participants or other users so that you can give access to the different services. So storing those keys and the secrets can be done via the keyword. So this is another layer of security we can consider. Application insight. So this is where you can monitor the predictive services in the workspace. Simply speaking, logs will be registered over the application insights. The Azure Container Registry is created when needed to store the environment images. So this is the optional resource. As and when you require, you can create this. So how do you create a workspace? First, let's understand what a workspace is. Workspace is basically, you can consider it as a laboratory. Like let's say you're working with the chemistry experiment. So what do you need? You need a lab where various apparatuses are there, where chemical compounds are there, and you perform those activities in those labs. Same thing for the machine learning. The workspace is provided by Azure Machine Learning. So you can create workspace in 4 different ways. One is you can use the UI in Azure portal, the one which I'll demonstrate soon. So it's a UI approach, visual approach with which you can perform a no-code approach. You can also jump down to Azure Resource Manager RM template. JSON-like template, you can fill out the details, you can implement that to create a resource or I would say workspace for you. You can also use Azure command line interface along with the Azure Machine Learning CLI extension. So this will help you out to create the workspace. Another option is if you want and you're comfortable, you can use Python SDK so that you can create a resource. So it is going to be Azure Machine Learning Python SDK. A small code snippet has been provided here. So what you will require is you will need a library called Azure AI ML Entities, import workspaces. To the workspace class, you need to pass certain details like what is the name of the workspace, in which location you want to create that workspace. And these certain basic details, when you pass it to begin and create to the workspaces, a workspace will be provided to you. Before I move ahead, let me show you this visually how we can create. So you can create a resource from the Azure portal with the UI approach as well. First, you need to sign in with your own credentials. Now, you can create a resource by clicking on Create Resource option. If Azure Machine Learning is available in the front page, you can use that. You can use search option by typing which resource you want to create or which service you want to create. And another option is using this portal menu. I'd like to use that. In the portal menu, you will find there is all services option. This is going to give you all the services of the portal, what Azure offers. Under the category of AI and machine learning, you will find Azure Machine Learning Service. Simply create a workspace. Now here, there are certain details which are mandatory and certain details which are optional. Let's look at the mandatory details like subscription. So there could be possibility you may have multiple subscriptions. Select the one which is required or I would say adequate for you. You need to select the resource group. Either you can select the resource group or you can create the new one to perform the activities. The workspace details, certain basic, like what is the name of the workspace? A unique name you need to provide, and a region in which you want this resource to be deployed. It is advisable to select the region nearest to your resource. So this region is basically a physical data center. You can select the one which is nearest to you, but that is just the advice. Based on the project requirement, you can select the one. The storage account, key vault, and application insights, the dependent resources will be created. For them, the name is required, which is auto-populated. If you feel you want to provide the name, you can simply use create new option. If you feel you want to associate the already available resources, you can select the one from the drop-down. As I mentioned earlier, container registry is complete option. So as and when you require, you can create it later. There is inbound and outbound access. So these are basically which network or via which network the service can get the access. You can provide either access or you can restrict it. So that can be done via the inbound and outbound. The encryption is specifically if you have any sort of data encryption. You can use this data encryption. Identity, let's say you are providing the resources to the different teams. So you want to give them some sort of access. Now based on which user, access may vary. So that you can perform via identity. And there is a tag. Now let us assume that this particular resource is shared by multiple different users or VPs. So if you want team-wise billing segregation, to do that, the name and value pair are required. So a consolidated billing can be created. Inbound access, outbound access, encryption, identity, and tags, they are completely optional. Also, they do have, like some of them do have the default values. So it will be auto-populated. Review and create. So it's going to be validated. And once the validation is passed, a resource will be created. As you can see, the resource is getting initialized. So based on which region we are deploying, what resource we are deploying, it's going to take some amount of time. Let's jump to the home page. Where you can see the deployment is in the progress, and it's going to provide us that deployment successful or the fail within few minutes. So let's just give a sec over here. When this is getting created, let's jump back to this deck. So when I was explaining how to create a resource, there was an option of the identity. What if you want to provide some identities, but you have not given them earlier? In this scenario, you can use access control from the Azure Machine Learning's resource page, the workspace page. There is access control management. You can provide accesses to the resources. There are various accesses like, let us say, there are certain pre-built or the general built-in roles, owner, contributor, reader. So if there is a user A who has created a resource, can grant user B the owner role. That means whatever resources the user A has created, all resources access user B will have. Along with that, user B can make user C owner or any other access control granting. If user A makes the user B contributor, whatever the user A has created, all resource access the user B will have. They cannot give access to user C. That's not possible. And what if the A makes the user B as reader? They will have only view access to the resources, but they cannot make any changes, neither to the resources, neither to the access level. There are certain built-in rules specific for certain tasks, I would say. So Azure Machine Learning, Azure ML Data Scientist, Azure ML Compute Operator, these are one of them. So Azure Machine Learning Data Scientist, now as a data scientist, what you need is you need to work on data to identify which algorithm fits for your data, or I would say the problem statement. So that whole process you can perform using Azure Machine Learning Data Scientist. But you will not have the access to create the, I would say, the computes, to delete the computes, to modify the computes. That can be done via Azure Machine Learning Compute Operator. What if you want to create a custom rule? Like, let's say I want to create something where the data scientist can have the compute operation, like they can create the compute, but they can't delete, something like that. So I can create a custom rule. I can give access to the users according. Apart from the access control, on the overview pane, you will find a button called Launch Studio. So this is the UI approach to work with Azure Machine Learning. It's an easy to use interface where you can create, manage, and use various resources and assets within the workspace. Let's jump back to the portal. Here you can see on the home page, let's say the resource group. I have created this demo. As you can see, Azure Machine Learning workspace is created. Along with that, the application inside Key Vault and storage created. And why this is there? Log analytic workspace. This is the dependent resource of application insights. So whichever resources are required, that will be auto-created. Let's look at this. Here you can see this is control management. So this will be available for the resource group. This will be available for individual resources and at the subscription level also. The roles, the one I was talking about, owner, contributor, reader, or else if I search for, let's say, Azure Machine Learning, the data scientist, compute operator, everything is available here. You can select the role which you want to. I would say give access to other users. Let's say add role assignments. Simply, let's say reader. To which member or to the identity, I can select that. And I can review and assign. Now, currently, I do not want to review or assign any roles to any user, so I'm just skipping that. So this is how you can perform via access control management. Let's jump to the overview pane. You will notice here which resource group, which location, under which subscription, what is the storage account detail, the container registry, if we have created that information, keyword, application insights, these will be there. Apart from this, there is ML Flow tracking URI. So ML Flow is an open source, I would say, a library or a platform which will help you to track your complete machine learning pipeline from the data ingestion till the evaluation, deployment, everything. Post that monitoring as well can be done via ML Flow. So where you can track that, all that information is available here. It does give us the Studio Web URL. Now either you can use this or simply just scroll and launch the Studio. So the Studio is basically your workspace UI approach where you can work with various different things. So let's understand. Now the workspace is basically what we can see right now. What is it? It's a top level resource for the Azure Machine Learning. The workspace is going to keep overview of everything like logs, matrix, all the outputs, models, and the snapshot of your code. So this is whole and soul of everything. As I mentioned earlier, the workspace is sort of a laboratory where you're performing all the details and everything is tracked. The machine learning resource does provide us the compute resources. So there will be 5 types of the compute. Let's look at them. If you jump to the machine learning studio, over here you can see compute instance, compute cluster, Kubernetes, attached compute, and service instance. Compute instance is basically you can choose from the GPU or the CPU as per the requirement. But this is a standalone system which will be provided to run your code. Based on requirement, you can select one. Compute cluster is where you can work with single or the multi-node compute. It's kind of, you can say, a cluster where as per the requirement, you can scale up and down. Kubernetes cluster is another type of a cluster where if you have a Kubernetes cluster or Kubernetes, I would say the compute, you can use that. Attached compute is basically, as you can see, there is Databricks, Data Lake Analytics, HD Insights, Synapse Spark Tool, and Virtual Machine. If you have the computational power which is created over any one of them, you can use that. The serverless instance is basically the whole underlying management is done via the Azure machine learning. So if you want to scale up, scale down, you do not need to think about it. Azure machine learning is going to take care of everything. So these various compute options are provided to you via the Azure machine learning resource. It does give data stores. So data will be stored in the data store, which are referenced to the Azure data services. So there will be 4 data stores by default. When we jump to the data, and let's look at the data store here. Here you can see a file share, blob storage, and file share. So 2 of file share and 2 of blob storage will be created. Let me just show you. Here, the storage account. If you will expand the data storage in the containers, you will find that 2 are created, the default blob storage. In the file shares, there are 2 which are created for the file shares. So these are default data stores which will be provided to you. Let's understand the Azure machine learning assets. Now for this, what I'm going to do is I will jump to the portal and let's start with the data itself. So there is the data asset. Now this data asset is where you're going to connect to your data. So let's say you can use the data asset to easily access the data every time. You do not need to think or to provide the authentication. So as a data scientist or machine learning engineer, if you do not want to worry about how the authentication will be done or every time do I need to authenticate, simply you can use the data asset. The jobs, any particular experiment which is running, all the information about that run will be available in the job. Either it is failed, either it is successful, either it is running, it's in the process, all the information will be available here. The component is a reusable piece of code. So it's kind of a building block which you can use. Let's say specifically you're creating a data processing component, you're creating model training, you're creating scoring. Now these can be reused for multiple different algorithms or different projects. So you can create a components for the same. The pipeline is where you're going to attach these components. So component attachment will be done in the designer. Let me just show you either custom component or the class of pre-built. So let's say I'm using this particular data and I have another data. Hypothetically, we'll assume. Now I want to create a merge data out of this. I want this data as the input and this data another. Now there will be a combined data set which I can use further down the line. Let us say I want to use it for the image transformation, so output, something like that. So these are the pre-built components which I can use in the designer. Once the job is executed, that job will be executed as the pipeline. So here, the component will be attached and you will find all the jobs. Environment. To run a specific algorithm, what you need is you need environments. So environment as well, you're going to specify software packages, environment variables, software settings, so that your script can be executed. So environment will be stored as an image and where it will be stored in the Azure container registry. So this container registry, let me just jump here. Just a moment. Yeah. So this container registry, what we have not created earlier, if you create your own environment, you're curating your environment, at that time, what you will require is the container registry. So this is about the environment. Let's look at one, the sklearn. So which version and all those, everything dependency is already installed. What if you want something of your own choice? You can always create according to your requirement via custom environments. So what is model? So the model is basically we are saving these trained models in the workspace. So let's say I have executed three algorithms. Let's say decision tree, random forest, and the logistic regression. Now I like the decision tree, the output. So what I can do is I can pre-package this as a model. I can register this. Generally, common way to store the model is to package model as Python pickle file. The script will be packaged as the pickle extension. Now these models I can use further down the line. So if you register models, the models can be used at yes, either at the real time or the batch endpoint, technically at the production level. These all various options are provided under the assets. Let's move ahead and understand about the authoring pane. Now, authoring pane does provide us four options: notebook, automated ML, designer, and prompt flow. The prompt flow, as the name suggests, prompt flow. So prompt is via the prompt, basically the natural language programming, or simply I would say the way we speak to each other. Via that you're providing instructions and the flow. You're going to set a particular path. What should be executed one after the other. So over here in the backend, the large language model will be executed. Using that, it is going to provide you the result. The designer is where the components will come into the picture. And using those components, you're going to process something. The notebook. Now let's look at the notebook. So notebook, you can create a Python file or you can create a like Python notebook, Python file, R, bash, various other options. And let's just create one. You can I can execute this particular one and the piece of code, whatever I have written, if my computer is up and running. So if you are a code first kind of a person, you can always use the notebooks for the same. And there is one important aspect is automated ML. This is a no code or a low code sort of approach. I'll come to that later. So when you are exploring the automated machine learning, basically, rather than you are manually testing or evaluating various configurations, automated machine learning can help you to do that. Multiple models will be trained in a parallel, a pre-processing can vary, and algorithm selections. So it's kind of a hyperparameter tuning we are doing, and it's going to provide you the best model for the one what you have passed and what matrix you have specified. Now this works on classification, regression, time series forecasting, computer vision, and natural language processing. Classification, as the name suggests, to predict the categorical value. Like, let's say the person is diabetic or non-diabetic. The regression, the example could be house price prediction. So you're predicting the numerical value. What if you're trying to predict the numerical value but based on the time data? And that is going to be future, like stock price prediction. So that's going to be time series forecasting. The computer vision works with the images. So if you want to categorize or classify the images, let's say, is it a flower or is it a tree, or you want to detect the object. So there are multiple objects and you want to detect them. For that, you can use object detection. Again, the computer vision. Natural language processing works with text classification. Let's say the email segregation in the inbox and spam. That can be done via NLP or the named entity recognition. Like, Joe went to London on Saturday. So I want to identify the name of the person, like person, where, that location, which date or day, so that's Saturday. So likewise, these things can be identified via named entity recognition using the NLP. And this can be done automated over automated machine learning or AutoML. So let's get started. What you need to do is your automated machine learning job. Simply let me collapse. You can provide a job name and the experiment name. So I'm just gonna keep it to the default. I need to select a task. As we discussed earlier, these are the 5 tasks. Let me select classification. Now to work with this task, what I need is data. So I'm gonna provide a data. Okay, let me just cancel this. I'm gonna go for regression and data one. The data, either it can be the URI, Azure storage, or local file. You will notice that I'm creating a data asset. So local file, where it will be stored in the blob storage. So let me just show you over here itself. Just give me a sec. Yeah, here as your blob store, and currently nothing is there. Okay, now next we need to upload a folder. So I'm going to upload this. Let me show you what's there. So there are 2 files. One is CSV and another is ML table. Let it validate and then we'll proceed further. While it's validating, let's look at this. Here there is a CSV file, what I'm using for this demonstration, like day, month, year. Based on all these parameters, we are going to calculate what is the rent of a particular pipe. So prediction is numerical, that's why it's regression. Now what this is, the ML table is basically a schema how to read that file. We are using this and a data asset will be created. We are going to select the data. Now what's going to be your prediction? So I want to calculate what the rent is. The configuration, now there are based on what you have selected, what task type, is it regression, is it classification? Based on that, the algorithm will vary. Also, the matrix are going to vary. I'm going to use it here, normalize root mean square, and let it use all the supported models for the data. If you want, you can block some, or you can use some. Also, I am asking it to explain me the best model. The featureization setting, what can be done is simply, as you can see, what is the column name? It's going to check the feature type auto. If you want, like you want to set it to numeric data, and you can pass it. If any data is missing, how it should be imputed, you can pass. Few of the data examples are provided here. You can set it accordingly. Non-mandatory details though. Limits also is a non-mandatory. So how many maximum trials, how many concurrent maximum trials, how many maximum nodes it can use. What should be the threshold or the matrix? Now, based on what matrix you have set, threshold will vary. So this is 0.085. Based on this threshold, now the algorithm is trying to gonna perform better. So total experiment, what should be the time? For individual iteration, what should be the time? So this iteration should be between 15 and 10 minutes. Let's say I'm providing here 20 minutes of total experiment. I can set it. But if I go beyond the experiment time, it will not allow me to do so. We can also enable the early termination. So what does that mean? If the model is not performing better, it will stop. Based on what? Based on the matrix score threshold, what we have set. The data, how you want, what sort of validation. So I'm going to go for train test bed. So 10% of the data will be used for the testing, rest all 90% will be used for the training. If you want, you can simply change this. So now it will be 80-20. If you have any testing data, you can add that. For this, what computational power you want to pass, you can select. I'm going to go for the serverless and submit the training job. So you'll notice once it is submitted, it is jumping to the jobs. Over here in the job, all the details will be provided. Currently, it is not started. In a few minutes, it will be under running. And then now there are multiple algorithms which are going to execute. Hyperparameter tuning will be done. Matrix will be checked. So it's going to take some amount of time. Maximum, the amount of experiment time, what we have said, that is 20. So between 20 minutes, you'll find the results of multiple different algorithms on the data. So here you can see now it is under running. I do have another resource which is created. Prior to this, let me just jump back to the demo and let me show you where that data asset is done. On the under the storage UI. Here you can see this byte data, which contains ML table and byte shell. So this is how the things will be uploaded to this. Now let's look at the another which already is been created. So if I jump to this, here I have created one, I would say the experiment. The same experiment, if you look at here, this is the one, how much time it took, and all the details will be provided. So this is the experiment. This was the best one. Here I can see all the matrix. Like I have requested for the normalized root mean squared error. But all the matrix, what it can capture, everything will be taken care. So how the things are working, all